So this lecture is on inheritance. So we've been working with inheritance all along, and I've kind of been mentioning it how all classes are derived from the base class object in C Sharp. But now we're going to really take a look at the syntax and actually see what you get when using inheritance. So inheritance is just a form of software reusability in which classes are created by absorbing an existing class's data and behaviors. So when you see something like this is inheritance. So it's saying my class, I want to inherit all of the attributes and methods from this object-based class. Also, when you instantiate a new form, that form, because it's inherited from the base class form, so you have that form1 colon form when you start up a new Windows project, that is telling you that your form is inheriting from the base class form. And so that's why you get everything that looks like a form. You can do this for any kind of visual component. If you wanted, you could create your own button, for instance. You could inherit from button, and you could add on elements to your own button. So this is called the base class, and this is the derived class, just so you have those keywords known. Always remember that the derived class is going to be more specific than the base class. C# does not support multiple inheritance. So languages like C++, you can actually have multiple parents for a given class. In C#, you'll only ever have one class over here that you're inheriting from. Now, there are something called interfaces that allow you to kind of get some of the benefits of multiple inheritance, and it takes away the drawbacks of multiple inheritance, and we're going to learn about that in another lecture. So in C#, when you have inheritance, the derived class, you can think of it as a is-a relationship. So a commission employee is an object, or from our other example where we created a vehicle, and then we can create, for instance, a car. We could say a car is a vehicle, for instance. So anytime you're using an inheritance, you're using that is a relationship versus the has a relationship. So if I was a commission employee and I instantiate an object in here, so this is a decimal, but let's pretend this was one of those date objects or something, that's a has a relationship because the commission employee has a date, for instance. Now, a derived class has access to all non-private members of the base class. So if there's private members in your base class, you still cannot access them via your derived class. You absorb them, but you cannot access them. So you would have to give a public property in your base class in order for your derived class to still access those. So let's go ahead and walk through this example here. So what we're doing here is we're going to create a commission employee. So imagine a business, and this is figure 11.4 from your book. You have a business now, and you have different types of employees. So the next few examples in the book, we're going to go over different types of employees you may have at your company. And so you're writing this application, and let's say you have salaried employees, you have commission employees, salary plus base employees. So you have all these different types of employees, and so the first employee type we're going to create is a commission employee. They only make money based on how much they sell and what their commission is on those sales. So this is everything that describes and makes up this commission employee. So again, you had this problem that you are trying to solve where you have different types of employees and you're going to have to write some sort of financial system to keep track of them. So this is one way you could break down that problem. Again, you're trying to create a class that contains just these very unique attributes to a commission employee. So we scroll down here, we've got a constructor, nothing new there. We have a read-only property because you'll notice there's only the get here. Same thing with last name, social security number, and then here's our gross sales. And you can see if you set it, we make sure that it's greater than 0. We also have the commission rate, and we have these earnings here, which is just the commission rate times the gross sales, so that when someone's using this class, they can calculate and get the earnings from this. And we're also overriding the toString method. So if we come over here, we've got this commission employee object, we're instantiating it, passing data in, and then we're just using this class like we've learned how to do, just accessing the public properties, setting the gross sales, and doing all of this. So this is just writing a normal class, and all it's inherited from is the object-based class at this point. So let's go ahead and take a look at the next example now from the book. So here's that exact same class. This is figure 11.4 that we just looked at. You can see there's nothing new in here, just everything we just looked at. But now we're going to look at this base plus commission employee. So now what this one is showing us is that we're creating, not only do we have the commission employee, but we also have employees that not only they get a commission so they can sell things and make money, but they also have a base salary. So your employee on the floor selling diamond rings, they make $50,000 a year plus, so much money for every diamond ring they sell. So okay, so now you created this class for base plus commission employees. So you can see by including inheritance here, we're getting everything that someone wrote for our commission employee. So what you could do is, this is where you could break up work. You could tell one person that they're going to write everything about a commission employee, and another that's going to write everything about a base plus commission employee. So now we make it more specific to what it means. And what does that mean? Well, this person gets a salary also. So this is their salary. Now we'll notice that for our constructor, we're going to have the user pass in all of this data. However, the data that is the exact same for our commission employee, so all of this data here, all we have to do is call that base class's constructor. So we can do that using the base keyword. So if you ever say base dot, you'll get everything, all the methods and attributes that are public in the base class. So that's what the base keyword gives you. So then we just make everything more unique. So we write our public property for our earnings. Now down here, they've actually done this on purpose for you. So you'll notice for our base plus commission, they're going to have a different type of earnings, correct? So if we go to our commission employee, what does it mean to have earnings for them? Well, it means to have commission rate times gross sales. Well, what does earnings mean for our base plus commission employee? Well, that's different, right? Not only do they get this, they also have a base salary. So sure enough, here's that exact same formula that we just saw. However, they also get a base salary. So for this type, we need to make this method earnings unique to base plus commission, because this is no longer accurate if we actually create a base plus commission employee. So why is it giving us this error message? Well, what we're trying to do is we're trying to make the earnings method more specific for a base plus commission employee object. However, we're trying to override it. However, we forgot to use what's called the virtual keyword up here in the base class, and that will allow us to override it here. So they did this on purpose. They just wanted to show you that if you forget that virtual keyword in the base class, this will not work. And you'll notice, because on the toString method, so the base class object had toString, they declared it virtual, so we were able to override it. Now because this is overridden, we can also override it here in the derived class. So now let's take a look at the next example. And we can see here now we've got our commission employee, so this is our original class. And you'll notice now they've changed all of these to protected. They used to be private attributes, now they are protected. So protected is an intermediary level of protection between public and private. So what it does is it allows your derived classes only to be able to see these attributes, but they're not able to be seen outside of this class. So if you just instantiate commission employee, you do not have access to these attributes. If you inherit from commission employee, you do have access to these. However, generally it's a good rule of thumb not to use the protected keyword. You usually want to use private keyword and then use public properties to control access, is generally a better practice on how to do this. So we scroll down here, everything's the same till we get down to our earnings method, and you'll notice now they've declared it with a virtual keyword. So when you're planning this out, you have to actually think ahead and say which methods may need to be overridden in my derived classes, because you generally know you're creating a base class and you know, hey, what are my derived classes going to be when you're designing and architecting everything out. And so you say, okay, I know I'm also going to have a base plus commission employee. Their earnings are going to be different and unique, so I'm going to have this virtual so they can override this method. So now if we go over here to our base plus commission that we were looking at earlier, here's just adding on salary. So now when we scroll down, you'll notice now I'm able to override the earnings method and everything seems to be working just fine. So when we come over here, how we can actually use this. So now we've got base plus commission employee. We've instantiated it, and you can see that, for instance, first name, if I right click on this, go to definition, this is actually part of my base class, right? Commission employee, not base plus commission. So that's showing you that you're getting that, you're inheriting that functionality when you use inheritance. So that's everything we need to show you there. So now let's go ahead and go back to our example that we've been working with, which is this car and vehicle example. So before we declared some vehicles, we had this vehicle base class, and we created some attributes and public methods and static attributes, if you remember all that. And so now we're going to add inheritance into this. So this vehicle class, remember, automatically inherits from the base class object. However, now we're going to change just a few things on our vehicle class. The first thing we're going to do is we're going to change this one to protected. So you can see model has been changed from private to protected. And so now derived classes can see this attribute. The only other thing that has changed now is this is a public method. I've added on the virtual keyword. So that means we can now override it in our derived class. So let's create a new class. So now we've got this car class. And inside of our car class, we want to be able to inherit all of the functionality from our vehicle class. So we go ahead and type this, start typing, we can see our IntelliSense comes in, press tab, and there we go. We've now inherited all of the functionality from our base class vehicle. Now we just add on attributes that are more specific to a car. For instance, spoiler type, or B has four-wheel drive. We create some constructors here. So we've got our default constructor where we just set these items. And we've also got our non-default constructor here, which also passes these items to our base class constructor. We've got properties that access our private attributes. And now what we want to do is let's go ahead and override that public method in our base class. And so this is nice about Visual Studio is as soon as you add things in up here, scroll some, get rid of some of these. When I put this code in here, it knows everything that exists in this vehicle base class, and it knows which things I can override. So as soon as I start typing public, and then I type the override keyword, I press tab space, you can see it pops up with all of the methods that I'm able to override. And all I have to do is, okay, I'll select this one. So just double click it, and you can see it actually fills it all in for me. And if I want to, it says, hey, did you actually mean to call this functionality up here? And it's like, well, we certainly can. Or maybe what we wanted to do is just say, S model equals Ford, for instance. So again, just with the base keyword, I can access things in my base class. Now, in that instance, notice I don't even have to use base dot. I was just showing you with that base keyword you could, because SModel has been, I'm already absorbing class vehicles, attributes, and methods. So I can call them just as if I had created them in my car class. I already have access to them. So again, if I can say base, this is a public method, or I can just say this is a public method. Now what's the difference between these two? Well, here's the problem. This one is actually referring to this one with recursion, and this one's calling my base class. So again, you have to be careful here now if they're named the same things. But if this was so just be careful there. So now let's go ahead and use this. So now over here, I've got this command create car click. Before we had command start click, which had all our vehicle classes. So now we're going to instantiate two cars, just calling our two different constructors. Now we're setting the attributes that are unique to our car. Now we're setting the base class attributes. Now what I'm showing you here is when I say car2 dot, now remember this is a car. It's inherited from the vehicle class. But when you're using car2, let's say you develop this car class and you distribute it to other developers. They don't even care that you've inherited from the vehicle base class. They may not even have any idea that you did that, right? All they care about is, hey, I need to use this car class and I need to be able to set all these attributes. And so when they look through here, right, they don't even see inheritance. They just see make, model, color, and things like that. So something like make right here, this is part of the base class, but you can see that they have no idea. It's just them using this class to get their job done. And that's the beauty of inheritance, is you just get all that for free. So we can see here we're calling the public method. Here we're calling those same static methods before. And so now we want to take a look at this is keyword. So this is keyword is really helpful with determining if an object is of type of a base class. So for instance, I'm asking, is this car of type class vehicle? And it is. Now the reverse is not true. So if I were to instantiate a vehicle class and say, hey, is vehicle a car? It's not. It only goes from derived class to base class. So car is a vehicle, but a vehicle is not a car. I think I said that wrong before. So just make sure you understand that. So this is also helpful, for instance, when doing like button clicks or label clicks. So let's go ahead and do this. Let's pop up our toolbox here. Let's just make this a little bit larger. Let's drag a label on here, and let's also drag a button. Let's come into our properties window. I'm going to select them both, and I'm going to handle the click event now for both a button and a label. And so don't be fooled. It says button 1 clicked, but both the label and the button are going to call this method when they get clicked. So the problem is I can't just say, label, my label, like we showed you in the tic-tac-toe example, label sender. We can't do that, and we also can't do this, button, my button. So both of these statements, so if I click the label, this one will be valid, but as soon as it hits this line of code, it's going to crash, and vice versa. So what we can do is we can use the is keyword. So we can say if sender is a label, else, if sender is a button, do this piece of code. And so where this is useful is, let's say you have maybe you're looping through a collection. So let's say you put both of these in a group box. Well, you can loop through the controls in a group box, and then you could use the is statement to determine which control you were currently on. So now let's take a look at our button click here. So this runs. Now if I click my button, you can see I come in here and I can highlight sender. We can see it's of type button here. So if I press F10, that's going to go to false. Is sender is a button? Yes, it is. So it comes into here. Now I can do that, and I can get a handle to my button and be able to access. If I click on the label, you can see it's going to go into the label code. So in later assignments, you may have like the airline assignment or something to that nature, where maybe you have a panel container, and then inside of that you now add these different items. So you can see if I move this around, see how they're now contained within my panel, or you can contain it within a group box, something like that. So this is called panel 1. So another thing I could do is do something like a for each statement. Let's change this to object. And so you notice I've got this controls property. Let's call this my object. So what is this doing here? So I'm saying, okay, go into my panel. All of the controls I want to loop through it. In each loop, go ahead and put each object into my object. But let's say I have labels in here, I have buttons in here, I have text boxes in here, but I only want to do things when one of these statements are true. So if I know if it's a label, maybe I don't do anything, and if it's a button, I actually need to handle, or I need to change a color or do something for it. So this is a way that you can loop through all of the controls in some sort of container, and then determine what type of control it is, and then be able to work from it from there. So that's everything for inheritance. The next topic I want to discuss is something called InTier Development. And we're actually going to kind of jump out of code. I'm just going to come over to a Word document and we're going to work through this step by step. So we're going to be talking about InTier Development. So what is InTier Development? So it's just a way that you can separate your application and your code into logical tiers. That's why it's called InTier, because you can have as many tiers as you want. Now, generally, the most common is a 3-tier approach. And so each tier is very unique and it does separate types of processing. And so what you'll generally do in an InTier application is you'll have 3 types of tiers. Again, you can have more, but the main tiers you're going to have is the presentation, the middle, and data tier. So let's just separate them out like this a little bit. And these are all in your lecture notes also, but I wanted to kind of write some stuff out here for you as we go through. So we've got our presentation, our middle, and our data tier. So our presentation tier is where the users interact with your application. So this is your Windows Forms, your WPF, or your HTML. So that's your presentation layer. So this is all of our GUIs, all of that code that handles button clicks, label clicks, that changes background colors, does user error processing with making sure the user input is valid, things of that nature. So all of that code you try to just put you abstract it out into a presentation layer. And so then you can also take some code and you can create a middle tiered layer. And so the middle tier is where your business logic is going to reside. So this was like that tic-tac-toe class that we've talked about, or employee class, or these examples we just looked at in the book for the base plus commission, employee objects. All of those sort of things all would reside in your middle class. So in reality, this is the smarts of your application. Has all the real rules, all the meat of your application. Now the presentation tier up here does not ever directly talk to the data tier. It has to go through the middle tier to talk to the data tier, and vice versa. So the communication goes between these different channels. Now our data tier, this is the server that stores all of our data. So this could be, our database, for instance. And not only is this our database like Oracle or SQL Server or MS Access in this class, a lot of times I like to create a code data tier also. And what this is, these are C# files that contain nothing but SQL. So in your final group project, you're going to be creating some stuff like this. You're going to create code in this class that contains nothing but all of your SQL statements. And the reason I like to separate their code out into this data tier like that is so, okay, let's say you now take your package, you've created this report, and it has a presentation layer, middle tier, and data tier, and you've abstracted out all of your SQL statements into a class, and now you're going to present that to your group at work. So other developers, managers, your customer, and your DBAs can all look at your code and analyze it and give you a peer review for it, and take a look, hey, this, your UI needs to be changed here, you're missing this requirement here, I can crash your program here if it has bad input. And then your DBA, they're probably not going to really understand a lot of the user interface in the C# code. However, they know SQL and they know databases. So you can point them to this one class you wrote that contains all of your SQL statements. Well, this is the world they live in, right? So they can look at this one class and they can go through your SQL statements and they can validate them for you or optimize them for you and make sure you wrote them correctly. So by breaking them out into these various tiers, it helps people review the parts of your code that they're most interested in. And it also helps you make the code more maintainable. So another thing that we put in this data access, this data tier is our data access class. So this is a C# code that we're going to write that actually connects our application to our database. And by separating that into this data tier, let's say we're using Oracle for a few years and then our customer says, you know what, this Oracle database is just too expensive, and so we're going to switch to SQL Server or a free database like MySQL. We say, oh crap, how much code are we going to have to rewrite? Well, if you write all of your database logic inside this database tier here, and your middle tier just simply calls the classes that you write in your data tier, your middle tier has no idea about the implementation. All it does is calls a method that says, hey, give me all of the employees in the HR department, for instance. The data tier takes care of all that logic, querying the database, querying which type of database, all the SQL statements. So the middle tier and presentation tiers never have to change. The only thing you have to do is you go in and you have this one class, this data access class that's connecting to an Oracle database. You change that class now to connect to a Microsoft or a MySQL database. Change it, and that's the only class you now have to update. And that's your code has now been changed over to a MySQL database. The middle tier still works exactly the same because it's calling that one class that got updated. However, it got updated everywhere now because it was being used in this one place. So that's another way, a good reason to separate some of your code out into this data tier. So what are some of the benefits? Well, now you can scale each tier independently. So what does that mean? So for your presentation tier, you can scale it in the sense that maybe you need different types of UI, moving it to a tablet, a phone, to Windows, so there's different ways you can scale out there. Your data tier, okay, if let's say you need more web servers, you need more database servers, things of that nature, so you can scale this out separately, and that doesn't affect the functionality of your middle or presentation tier. It just affects this one tier, so you can add more servers on, for instance. Next thing is you can maintain each tier separately, which in the real world, lots of times so after you deploy code, it's locked down, and you need go through all kinds of paperwork to update one line of code in a lot of situations. So what's nice is if you abstract them out this way, you can maintain and update your presentation layer, and you're guaranteed to not have broken anything in your middle or data tier. Same thing if you update your data tier, you're guaranteed not to have broken anything on these other layers. Another benefit is reusability. So by breaking it up this way, you can reuse these tiers independent from each other. So for instance, the business logic in our middle tier. So what I mean by this is that, think back, let's go to our tic-tac-toe program. Now if you had done this properly and you abstracted out all the tic-tac-toe logic into a C# class, right? That's the middle tier layer. Now when you did this, that middle tier knew nothing about WPF. It knew nothing about HTML. It knew nothing about button clicks. It knew nothing except, hey, pass me in a string array, and here's my processing to say if there's wins or losses. And it's all just pure C# code. So it doesn't know anything about the presentation layer. It doesn't know if it's a Windows Forms application, a tablet application, a web application. It has no idea. So if you were to break the code out this way, then all you have to do now is, okay, I'm writing a Windows application. I can call this middle tier. And then the customer comes to you and says, you know what, we actually want to put this tic-tac-toe game on the internet. All right, so now you create a new presentation layer with HTML, and now the middle tier logic stays exactly the same because you just have a button click on your internet. It goes back to your web server and uses that exact same C# class. And because you wrote it that it didn't know anything about presentation layers, you can use the exact same code, and now you've just ported this tic-tac-toe program from a Windows Forms application to an internet application on the web. So that's kind of some things to keep in mind as you're creating your applications, that not only do we want to abstract things out into these classes with your business logic, you want to keep them logically in these different tiers. And so far we've just been working with these two tiers, but always keep that in the back of your mind. Keep your presentation just with knowing about Windows Forms, button clicks, a little bit of user validation. Keep it as dumb as possible. The middle tier should have all the smarts inside of it with all your business logic, handling complex validation, and then it should be talking to your data tier, which then handles everything going to the database.